Okay, hi guys, welcome back to lecture 5. Today we're going to do unions and intersections and complements of sets and Venn diagrams. Some of this stuff you will have seen before. Okay, so we're going to just start off with some simple definitions here. Okay, if A and B are sets, then the union of A and B is, so first of all we write it this way, A and then this kind of like U symbol, B, and here's what it is. It's the set of all x such that x is in A or x is in B. Okay, now let's do intersection. The intersection of A and B is, so we write A and then it's the same symbol as union except upside down like a horseshoe. Okay, and it is the set of all x such that x is in A and x is in B. You see, the word or goes with union and the word and goes with intersection. Okay? Now I did not write this name up at the top on the title of the page, but we're also going to do what's called the difference of A and B. Now, this is important. The difference of A and B is different than the difference of B and A. Okay, the difference of A and B is, we write it like this, A minus B is how we write it. And it's the set of all x such that x is in A and not in B. All right, so those are three important concepts. Let's practice those. Let's say A is the set 1, 2, 3, 4, 5, and B is the set 3, here let's do actually this, let's do 2, 4, 6, 8, 10. Okay, so let's find A union B. That would be everything that's in A or in B. So it would be 1, 2, 3, 4, 5, 6, 8, and 10. It doesn't matter what order you write them, but I'm just writing them in an order that makes sense to me. If you're trying to find A union B, it makes sense to just write down everything in A and then add in the stuff from B that you haven't already written. Okay, now let's do A intersection B. That's the stuff that's in A and B both. So what is that? I only see two numbers, 2 and 4. Okay, let's do the difference of A and B. That's the stuff that's in A but not B. So that would be 1, 3, and 5. Okay, and for practice we better do b minus a too. Find that difference. What would that be? The stuff that's in b, but not in a. That would be 6, 8, and 10, right? Okay. So that's not too hard, is it? Now let's do another one. Let's do complement. The complement, spelled with an E after the L, not an I, of A is, and we're going to write it, this is the way they write it in the book, is an A with a bar over the top. And here's the definition. It's a set of all x such that x is not an element of A. Now we're not going to do that for the example I've written in gray. It'll be too many numbers. Okay, but I want to go over a little bit more about complement. If you look it up in the book, it's written a little differently, and I want to go over that as well. Okay, there's this idea of what's called a universal set. Let me write this. I'll write this in gray. Okay. The universal set is the set of all possible things of the type under consideration. That's very vague, I understand that. Oh, and let me put in parentheses. It is usually implied, but not specifically stated. Now, I know that's very vague, but let me say something about that. Okay, suppose you say A is, how about the set of positive numbers? Okay, and then what if I asked you, what is a complement? You could say, what's the set of all numbers that aren't positive, right? That would be accurate. That'd be correct. The set of all numbers that aren't positive. But here's the catch. Somebody might say, are we talking about real numbers or complex numbers? Ah, you see, that makes a difference. If we're talking about real numbers, then the set of all numbers that aren't positive would just include 0 and all the negative numbers. But if you're considering complex numbers and then you take out all positive numbers, well, then there's a whole heck of a lot more numbers still left over, isn't there? So in this case, the universal set would either be the real numbers or the complex numbers. And it needs to be made clear. It's usually implied though. Okay? But the reason why I wanted to bring it up is because you'll see in the book, it has this definition. It has A complement equals the universal set minus A. Okay, so that means all of the stuff that exists that's not in A, but when I say all of the stuff that exists, it needs to be clear, what are you considering as existing? I mean, are you just only considering real numbers, or are you considering complex numbers, or are you considering letters? You know what I mean? If A is the set of vowels, let's say, then you would say A complement is the set of consonants, right? But that's only assuming that your universal set is our English alphabet. You see what I'm saying? And usually we won't say, if I said, what are all the letters that aren't vowels, you wouldn't hear me say, what are all the letters in the English alphabet that aren't vowels? It's usually understood. It's implied by the question, or by the stuff you're doing at the time. Okay? All right, where else are we here? We got union, intersection, difference, complement. Okay, so now I want to do Venn diagrams with you. I bet you've seen these before, probably. A Venn diagram is just a graphical, visual depiction of unions and intersections of sets. Okay? Suppose you want to do, you want to depict A union B visually. So the way to do that is to draw a circle for A, and then another circle to represent B, and you link them. Doesn't matter if they're the same size or not. I know those are a little different. Okay? And let me label them, okay? Okay, and A union B is the set of all the stuff in A, so that would include all of this stuff. And also all the stuff in B. So that would be A union B, would be that. Okay, usually we like to keep it where you can still see the lines for the sets. So you see it like that. That's A union B. Okay, let's do A intersected with B. Or, I mean, that's another way of saying A intersect B. The intersection of A and B is often referred to as A intersect B, or A intersected with B. So that would be where you just shade the stuff that's in both A and B. That would be this stuff. Okay? Let's do a Venn diagram for the difference A minus B. Okay? So if that's A and that's B, then A minus B would be everything that's in A but not in B. So that would look like this. Think about for yourself what B minus A would look like. Okay. Let's do a Venn diagram for the complement of A, or A complement. Now, let me go ahead and put a circle here for set A. Okay, we're doing A complement. Now, in order to do that, well, I have to shade everything that's not in A, right? So that would be shading everything except that circle. Well, let's not get carried away. I'm not going to shade the whole screen. So what you do is you draw a rectangle. That's the universal set, is the rectangle. So that's everything as far as you're concerned. That's everything that exists. Okay? And this circle is A. And the complement of A would be everything that's not in that circle. I don't want to spend too long doing it, so I'll be a little bit sloppy, but the point is we would shade everything that's not in that circle. Okay, that would be A complement. Now, let's try it with 3 different sets. Let's say A, B, and C, and let's graph some different unions and intersections and complements and things. Whoops, I did not mean to do it that way. So that'll be one of the sets. Okay, and then there's another. And then there's another. You always draw them so that all of the sets link each other. Okay? You might say, well, what if the 2 sets don't have anything in common? Then you just don't shade the part where they overlap. I mean, that would be empty then. You see what I'm saying? Okay, so let's call this one A, and this one B, and this one C. And let's do several different problems here. So how about if you wanted to do, oh, and let's also do this. Let's put a universal set around there. Okay, so what if you wanted to do, I'll do this in blue. Let's do the intersection of all 3. What would that be? That would be this little part here. That's the stuff that's in A, and it's also in B, and it's also in C. Okay? Let's do A intersect B union C. So that's everything that's in A and B, so that would be this stuff. Along with everything in C. So that'll pick up that and this and all of this stuff. That's the set of all x such that x is in A and x is in B, or x is in C. All right? What if you wanted to do, let's do the complement of A union B. So that's everything that's not in A union B. Well, if you want to, we can shade in another color A union B. That would be A union B right there, correct? So the complement of that is absolutely everything else. That's all of this stuff, first of all, but also all of this stuff in here too. And so let me take away, oh, I didn't want to take away the circle. Let me take away the red lines now. Okay, so there's the complement of A union B. It just gives a very nice visual representation. Okay, so I think that's about it for this lecture. It was kind of a short one. We did cover, though, several sections in the book. Actually, 3 sections. Intersection, union, and difference is one section, complement is another section, and Venn diagrams is another. But you should be reading the book too, along with these lectures. Please be doing that. All right, have a good afternoon.